So hello everyone, welcome back to a session, and today we are going to discuss the important chapter from the physics, and that is electricity. So guys, if I talk about this chapter electricity, what is it? What do you think? What is electricity? So there's an animation in front of you. Just see, there's a person who's ringing the bell, and while ringing the bell, he's feeling shock. So how he gets this shock? Let's understand about it. So as what happens when he is trying to press the bell, you can just see that there is a charge that is flowing. What is it? Charge, and that too, it's a negative charge. So guys, there was a term in the geography, if you remember, and that was water current. Remember? So what do you mean by water current? Water current is nothing but the flow of water. What is it? Water current is actually the flow of water. In this similar manner, if someone asks you about the electric current, what is it? That's the flow of charge. Yes. So charges are of basically two different types. It may be positive or it may be negative. So yes, that flow of charge is current. Now, if this charge is flowing in, if this charge, let's say it's negative, it's flowing in x direction, the current flows in the opposite direction. But if charge is positive in nature, wherever this charge will flow, the current will flow in the opposite direction, sorry, in the same direction. So these questions were from your previous year part. So yep, this is the basic from this chapter. Now let's proceed and let's understand about it in detail further. Okay, so guys, what we are going to discuss today, first of all, we'll understand what is electric charge, then also we'll understand about the electric current, and finally we'll understand what are circuits. So let's start with the electric charges first. So what is it? So guys, if I'll talk about this electric charge here, one second, I have to use it. Yeah, okay. So guys, talking about the electric charges as discussed, here, if I'm talking about the flow of charges, so it might be positive or negative. So in order to understand about it in a better way, let's have a look at the structure. This is the atomic structure in which the center is nucleus, and the center includes the protons and the neutrons. Protons and neutrons are collectively known as nucleons, which are there in the center, but electrons are moving at its particular path, that's the fixed orbit. So yes, the outermost shell's electrons are actually known as valence electrons, and they are actually free to move. That's what it is mentioned here. So atom consists of the positively charged nucleus that includes nucleons, which means it is consisting of the proton and the neutron. But there are negatively charged electrons which are there in the outermost shell, and they are fixed at their path, that's orbit. So valence electrons are free to move within the conductor, and they constitute an electric current. So atom consists of proton, neutron, electrons. We are aware of this. But what is charge? So charge is an intrinsic property of a matter by the virtue of which it can exert electromagnetic force. And the value of the charge on the electron is mentioned here, that is minus 1.6 into 10 to the power minus 19 coulomb. So yes, what is the unit of charge? That's coulomb. Fine. Now the point is, so what will happen if same charges are present, and what will happen if opposite charges are there? So if same charges are there, they are going to repel each other, and if they are opposite in nature, they are going to attract each other. So let's proceed with the same and let's understand about it. So here, what are conductors? So conductors are those substances that offers comparatively lesser opposition to the flow of current, and insulators are the ones that offers a larger opposition, right? So here, see, if the charges are opposite in nature, so they will attract, but here both the charges are same, so they are repelling. So whether it is positive charge or it is negative charge, if both the charges are same, they are going to repel each other. So that's what is mentioned here. Two objects with the same charge are always going to repel. And yes, if the charges are opposite in nature, they'll obviously attract each other, and that's the basic point. Now, if we are talking about charges and we have not discussed about Coulomb, that's not possible. So the discussion of the Coulomb is important. So guys, according to the Coulomb's law, what is it? Force is directly proportional to the product of the charges and inversely proportional to the square of distance between them. But if I want to remove this proportionality part, what I'll do? I'll use K here, and that K is equal to 1 upon 4 pi epsilon naught, where epsilon naught is the permittivity of the free space. So the same thing is mentioned in the theoretical portion. the force of attraction or repulsion between the two charged bodies, they are directly proportional to the product of their charges and inversely proportional to the square of distance between them. And here's the formula. K q1 q2 upon r square, or we can say d square, that's basically the distance, and k is equal to 1 upon 4 pi epsilon naught, where epsilon naught is the permittivity of the free space. As simple as it. Okay. So now guys, finally we are with the subtopic, that is electric current. So what is it? We have already discussed that's the flow of charge, right? So let's have a look here. Electric current is a continuous flow of electric charges through a cross section of a material. It is a scalar quantity. Yesterday in our class we have discussed this using animation. If you remember, we were talking about scalar and vector quantities. What was it? So sir, if I talk about the scalar and vector quantities are the ones which have just magnitude and no direction. But current has both magnitude and direction. Then why? Because current doesn't obey vector law of addition. Because it is not following the vector law of addition, so that's why it is in the scalar category, right? So do not forget, this is the important one, as we are aware of that distance is scalar and other things are scalar, but current is again scalar. So distance, current, both the things are scalar. Also the speed. Fine. Okay. So if you have any doubts here, you can just let me know. Otherwise, we can just proceed. So let me check the comments. So everything is clear. Fine. So now guys, what is the unit of the current? That is ampere, and the amount of charge passing past a point in a certain amount of time, that's what current is. So with the formula, that is I is equal to Q by T, where Q is the charge, T is the time, and I is the current. Okay. Now guys, in order to measure this current's value, do we have any device? Yeah, we have. What is that? So that's the device that is known as ammeter. So ammeter is a device that is used to measure the value of the current. So just have a look. So this is ammeter. So in the simple terms, we can just link it. The meter that is measuring the ampere value, that is a meter. So it's an instrument for measuring either the DC or AC, that is the direct current, or the AC current, that is alternating current. And in order to understand about it in a better way, I'll just take the simplest example. Let's go with a graph, and that would be the best part to understand it easily. Let note open. So here we'll understand what's the difference between the AC and DC. So first of all, tell me, are you aware of what is frequency? What is amplitude? If you are aware of this, it would be easy. Or else I'll do one thing. I'll just use my teaching board first. Yes. And here, okay. So guys, here, if I try to draw a graph, what you can see, you will see this is a straight line that is formed. So guys, if someone asks you what is the frequency here, what you will answer? So you will say it's a frequency. If you will talk about frequency here, so I cannot see any waveform. There is no positive cycle, there is no negative cycle. So what we can say is, there is no such positive or negative cycle. So what do you say? You will say, so the frequency here is 0 hertz, right? But taking another example, I'll just take white color again, and let me make a wave here. Now here, this is the positive cycle and this is the negative cycle, the positive again, and it continues. So if someone asks you what is amplitude here, so what do you say? You will say, so the maximum displacement that I can see here is this one. This is the maximum displacement. 1 second. It would be better if I'll change the color. Yeah, here. So the maximum displacement either here or this one or this one. Because if I try to calculate this one and this one, they are actually the lowest values. So if I talk about the peak values, the highest values, that's present here. So this value gives us the amplitude. What it gives? It gives the value of amplitude. So amplitude is actually the maximum displacement of the particle, which you can just see here. Now, what about wavelength? So if someone asks you about the wavelength, so distance between two crust or two trough, the distance between the two crust or two trough, that is known as wavelength, which is represented by lambda. And this was amplitude. This is what amplitude is. Okay, so we have understood the amplitude also and wavelength also. But guys, still I have a doubt. What about frequency? So guys, when we talk about this cycle, that is the crust and the trough part, so this positive cycle and this negative cycle, they complete their whole cycle over here. That's the complete cycle, right? So the number of oscillations per second, what is that? The number of oscillations per second represents the frequency. So what is frequency? That is the number of oscillations per second. So we can write H hertz. But in this case, tell me, are you able to see any sinusoidal wave? Sir, is there any frequency possible here? No, because we are unable to see those number of oscillations, right? So here the frequency is 0, and this is the example of a direct current where frequency is 0. That's the example of a direct current. But guys, if I talk about the alternating current, for the alternating current, you have the frequency of 50 hertz in India. So in India, you have the frequency of 50 hertz, and that is important. Understood? What about USA? So guys, please remember, for the US, for the United States of America, the frequency that is used there is of 60 hertz. Okay, so now this part is also clear, right? So proceeding further, we have understood about the ammeter now. So here, now what is potential difference? So guys, you can link this potential difference with the voltage. So what is it? Here there's a pencil cell, or we can say talk about a dry cell. So here that's the high potential, this is at the lower potential, and current always flows from higher potential to lower potential. So that's what potential difference is. Just see, there's a difference in the potential. So this is potential difference. So work done in bringing a unit positive charge from infinity to that point is electric potential. So because of this difference in the electric potentials, current is able to flow here. Just see, current is able to flow, only then this bulb is glowing, right? So electric current always flows from higher potential to lower potential. It is measured by a voltmeter, and that's work done upon charge. This is what potential difference is. Okay, now how we can measure it? So for that we have a device, that is voltmeter, and yes, we have multimeters as well, by which we can calculate different values. So yep, so that's the term for the potential difference as discussed. Unit is volt, and electric potential energy per unit charge. Okay, then we have resistance. What is it? So guys, if someone talks about the resistance, so it's just the obstruction in the flow of charge. So let's say if charge is flowing, obviously what is current? That's the flow of charge. So if there is obstruction in this current or the flow of charge, that's what resistance is. So this value depends that how much obstruction is applied there. So if it is of a higher value, it will be more. If it is of lesser value, it will be lesser. So is there any unit for the same? Yeah, there's the unit, that is ohm, right? So what is resistance? It is the property of a conductor which resists the flow of electric current through it, and the SI unit is ohm. So is there any relation with the length or the area? Yeah, there is. Resistance is directly proportional to the length and inversely proportional to the area of cross section. And if you wanna remove this proportionality sign, the formula that you have is R is equal to rho L by A, where rho is the resistivity, right? So here resistance depends upon the nature, length and area of cross section, and because of this we have a formula that is R is equal to rho L by A, where rho is the resistivity, L is the length and A is the area of cross section. Guys, if you want to solve the numerical, I have a numerical as well for you. So if you have any doubts or queries, you can just let me know in the comment section as of now, and then I'll proceed further. So if there's any comments, let me check. So everything is sorted, right? Okay. So now guys, If I talk about this Ohm's law, what is it? So voltage across a conductor is directly proportional to the current flowing through it, provided all the physical conditions and temperature remains constant. So from here, if the conductor is ohmic in nature, voltage is directly proportional to the current. And if I want to remove this proportionality sign, what I have to do? I have to use a constant, and that is R, that is resistance. So from here we get the formula, that is V is equal to IR, and here that's the one. So V is equal to IR, where V is the voltage, I is the current, and R is the resistance. So in order to understand it in the better way, I have a simple question. Let me see how many of you can give the correct answer for the same. Okay. So guys, here's a question for you. Let me see how many of you can give the correct answer here. So this is the question that is asked in the examination. The question is, a wire of resistance 10 ohm is stretched to triple its original length. What will be its new resistance? What do you think? What will be the correct answer? So just try to solve it. So guys, here what is given? We are given with the value that the resistance is of 10 ohm, and then the wire was stretched to triple its original length. So length was tripled here. So now guys, tell me one thing. Will there be any change in the volume? Is volume going to change? So volume is going to remain same. Volume will be remaining same. But in this formula, we were talking about the length and the cross-sectional area. So there's obviously there will be change in the cross-sectional area, right? So for this, a wire of resistance 10 ohm is stretched to triple its original length. What will be the new resistance? So here, what will be the formula for the new resistance? Tell me. So if I talk about the new resistance, it will be, that will be the value. So that's the formula that you must remember in this case, because when volume is same, obviously there will be the change in the area of cross section because there's a change in the length, right? So here it's how many? Triple, right? So 3 square into 10 ohm, and it is going to give me the new value to be 90 ohm. So do not get confused. These type of questions are asked in the examination, and yes, those days are gone where these simple questions will be asked. Okay, so you're putting the value of resistance, you're putting the value of length, and you calculate the area. No, these questions must be logically understood, and that's why the answer will be 90. In most of the cases, the candidates will go with 30, but 90 is the correct answer, right? So here, the important thing that I wanted to say, when the length is, or when the wire is stretched, volume is going to remain constant as discussed. But if the length increases by factor n, the area decreases by n. Now this is important. If length increases by the factor n, there will be the change in the area, right? And the new resistance will be r dash is equal to n square r, and it is going to give me this particular value. So yep, these type of questions are asked in the examination, but do not worry. Since I've already told you, you will be getting the free ebook from this week itself. So in the starting 3 days, we are discussing all those important topics that are relevant to the examination. And finally, on the 4th day, we'll have the practice of almost 100 questions, which are the important ones. And this time, this session will be on Friday, because tomorrow is Thursday. Tomorrow, we'll be discussing the mechanism. So the chapters that we have discussed is, yesterday we discussed scalar vector quantities. Today we are discussing electricity. Tomorrow we will be discussing the mechanism. So there will be the combined questions from these chapters, and yes, we will discuss them with the, and those includes the PYQs, also the most expected questions, and also the free ebook will be given to you people. Okay, so proceeding further, that's done. Yeah. So guys, direction of the electron flow and the current flow. So here the sphere n contains what? So sphere n has a negative charge, and this sphere p has positive charge. So sphere n has excess of electrons in comparison to sphere p, as we can see in the image, right? So here the electron flow will take place from n to p. Why? Because just see, the charge is level. So electrons, when they are flowing from n to p, I have already discussed this in the very starting, that if charges are negative in nature, so wherever the negative charge will flow, the current will flow in the opposite direction. and current is always flowing in the same direction of positive charge, right? So here current flows from P to N, and here also heat will be produced in the conductor when the current flows. So this is the basic phenomena. We have seen that if we are using heaters, we are using any of the electric equipment, and after some time when you will try to touch the wire, you'll feel like that it is actually heated up, right? Why is it so? Because when you touch that when you touch that wire, because of the flow of the current, that wire starts to heat up. So is there any relation between the same heat and the current? So yes, heat is directly proportional to the square of the current. What is it? Heat is directly proportional to the square of the current. And here we are going to discuss the Joule's law of heating effect. And according to the Joule's law of heating effect, guys, according to the Joule's law of heating effect, here the formula is H is equal to I square RT. And I'll just show you here. See, so when the circuit gets completed, the current starts to flow and this bulb glows. So according to the Joule's law, this is the formula, that is H is equal to I square RT. That's the point number one that you need to remember. Also, please remember the relation between the power and all those things. So yes, P is equal to I square R. It's is equal to VI as well, and that's equal to V square by R as well. So that's the relation between the power, current, and the resistance. Any doubts? All clear? Great. So guys, here we have completed this part also, and the final part of our chapter is circuits. So let's have a look at it. So what is circuit? Circuit is basically a path through which electricity can flow. What it includes? So circuit includes an energy source, one or more loads, and the conductors, where you can talk about wires. So here, what is the energy source? So energy source, here you can talk about the batteries. So circuit needs energy source to push us charge through the circuit. So it will be battery, it can be a cell, it can be anything. Then load. So device in a circuit that operates using electrical energy. So it may be bulb, tube light, laptop, computer, it may be anything, right? Then conductor, material that allows electrical energy to flow through it easily. Wire. That's it. Then resistor, that is resisting the flow of electrical energy. It inhibits the flow of current, producing a voltage drop when current passes through it. So this limits the current, causes some electric energy to be given off as heat. And what is that formula? H is equal to I square RT. Cool. Okay. So guys, yeah, switch is also left. So that's a device that is used to control the flow of current through a circuit. It works by separating the two conductors, bringing together two conductors attached to a circuit. So let's see. Circuits are of two different types. One is series, another one is parallel. So series circuit provides only one possible path for the current to flow, and parallel circuit offers more than one path for the flow of electricity. What they are trying to say? So let's have a look about it here. Let's say here is the resistance provided, and let me write the value for the same. So let's say this is of 3 ohm and this is of 5 ohm. Now tell me one thing, if the current is flowing through it, let's say 5 ampere current is flowing through it. So guys, here how much current will pass? So current has no other path, it has a single path. So here also the 5 ampere current will only flow. Again, here also 5 ampere current will flow. That means current doesn't have any path to change its direction, or we can say, sir, it is not going to split. That is the perfect way to explain this. So this type of circuit is said to be series circuit. What is it? This is the example of a series circuit. But if the current has two or more than two paths, at least two paths, that circuit is known as the parallel circuit. What is that? If the current has two or more than two paths, it is said to be the parallel circuit, and that's what it was mentioned here. So in the series circuit, it provides only one possible path for the flow of current that we have seen, and if it has multiple paths, that's a parallel circuit. So here, see, in the series circuit, current has only a single path. So when the current was flowing, so this bulb, then this bulb, then this bulb. So this is the series circuit. So the loads are set up in a series here. It requires current to flow through one load before passing to the next, and the overall resistance is given in this way. That is, you are just going to add up all the resistances. So where these type of connections are found? In the Christmas lights, on the Christmas tree, voltage divider, resonant circuits, analog filters, they all are the examples of series circuits. Also, Diwali lights. So guys, you might have seen this example. If one of the light in the Diwali, during Diwali festival, if one of the light is not working in that whole structure, so other lights also stops to glow. Why? Because that's in the series circuit. So in order to again light up the whole structure, what do you have to do? You have to just take out that fuse bulb. You will just tight that wire, you will just tape it and then connect it. Whole wire will all the bulbs will start to glow again. So that's the perfect example of the series circuit. But if I talk about the parallel circuit, so here the current has multiple paths. See, when the current will be flowing, it has multiple paths to go. So here I current was there, but here I1, here I2, here I3. So yes, the current is actually dividing here. So each load has its own path for electricity. The resistance is calculated by using this formula, that is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. And here the examples are amplifier, oscillators and home lights. Right. So that's all from my end. We'll meet in the next class now, and in the next class we'll discuss about the mechanism. Yes, if you have any doubts, any queries, any questions, you can just drop a comment in the comment section and you can just let me know your doubts. I'll respond personally there. And also, do not worry about practice questions, because I've already discussed this is going to happen now every week. You will be getting a free ebook that I'm preparing for you people. So yes, yesterday we have discussed scalar vector quantities, today we have discussed electricity, tomorrow we will be discussing the magnetism, and day after tomorrow we'll have a practice session which will include all these three topics, and that session will include the PYQs, that is previous year questions, and also the most expected questions, and everything can be solved from this YouTube itself. So please let me know, are you liking this series? So I want this answer in the comment section, and also there's a homework question for you all. Guys, please tell me the lights that are connected at your home. So the connection that is there at our home is parallel connection or is it a series connection? So please answer me this in your comment section. And also, if you want to join any of the paid batches, what you can do? You can just go to the Google. You will just type Oliveboard there, and on the first link, just click there. And here you have the toppers from SSCGL, AIR1. Then we have AIR 4, 3, 6, 14. So yes, we have all these AIRs. I just want in the next result, your name should also be mentioned here. Okay, so for the preparation, you can go to the dashboard. Here you will find SSC plus Railway Super Elite batch, which has both Hindi and English courses, live courses, tests, and other things are also here. That is like notes and all. So you have 1200 plus live sessions of the SSC, 600 plus live session of the RRB, 900 plus mock, typing test. All these things are present here. What you have to do, just click on the Enroll Now option. And right now there's a discount code, that is select is going on. So you can use the select code to get 45% off and also the double validity on the course. So you can just click on it and type the code select. And once you type it, you will get the maximum discount. So that's all from my end, guys. We'll meet tomorrow with the new chapter, that is magnetism. And please let me know in the comment section, are you liking the series? Take care, guys. And for the examination, all the very best. Take care.